I'm Greg Aune. I'm a physician scientist and a pediatric oncologist in San Antonio, Texas at Greehey Children's Cancer Research Institute. I grew up on a farm in rural eastern Washington and probably would have never been a doctor, but from some life experiences, mainly being diagnosed with Hodgkin's disease when I was 16, it really put me on a different path. I mean, obviously, being told you have cancer at age 16 is kind of a life-changing event. It kind of turned my life completely upside down. I was really interested in sports. I was a good student, but if you would have asked me then, what are you going to do? I was going to play college football. I got about a year and a half of treatment, chemo, radiation, surgeries. It was pretty, I would say, horrific. I lost about almost 80 pounds of weight. At one point, I didn't eat anything by mouth for about 3 months. So the toxicity of the treatments, I think, really impacted kind of my perspective on oncology, and it really was kind of the initial seed for research. I always say getting diagnosed with cancer was the worst thing that ever happened to me. It was probably my biggest blessing because I think it really put my life on a different path. It made me want to do things for others and try to make an impact, and I think that's driven me all the way, and it still does today. I developed severe cardiac disease from the treatments that I'd had, which is something that really has come to the forefront in the last 10 or 15 years in our pediatric oncology, and we're now seeing, unfortunately, a lot of patients like me. And at age 35, I had open heart surgery to replace my aortic valve and bypass 3 coronary arteries. So it was a major life-changing event. It really changed my perspective on what I wanted to do. And so, from there forward, I think I just kind of reevaluated what I was going to do for my research and started looking into what we do understand about how our treatments that we use in the 21st century for childhood cancer that lead to great cures, how do they actually cause toxicity that results in someone having heart problems 20, 30 years later? And so that really is kind of the major drivers to what I work on in the lab. The funding from the Hyundai Hope on Wheels grant, I think, really came at a critical point in my development as a young investigator, meaning that we were just kind of getting a couple major efforts up off the ground, and that funding came at the right time to hire additional personnel, 2 really bright MD PhD students that I think, because I had that extra funding and it was obvious that my lab was heading in that direction, wanted to work in the lab. So I think all of that began, with those initial, investments from the Hyundai Hope on Wheels grant. I'm really interested in this problem of late cardiac complications from cancer therapies in children. By 2020, we'll have about 500,000 survivors of childhood cancer in the United States. And of that population, half have gotten a group of medicines called anthracyclines, which we now know carry a fairly significant risk of causing heart failure over time. So if you look at those patients that have received anthracyclines by age 50, it's generally accepted that about 20% of them are probably at high risk of having heart failure. It's an irreversible condition. The only treatment is actually heart transplant. So it becomes really important to study this process over a lifespan. In clinical world, it's really not feasible because we're talking studies that would last 30 to 40 years. They would be cost prohibitive. No one would fund those. It's hard to follow the patient. So really the mouse is kind of the ideal tool in which to study this problem. And so we asked a very simple question. There's a common medicine we use to protect the heart that hasn't gained widespread acceptance, and we actually modeled it in a mouse to see if we took this medicine and gave it to mice when they were young and looked throughout the lifespan of a mouse, would it actually protect the heart? And we confirmed that it would. I think when it comes out, I think we're going to try to argue that it's more evidence that we should be giving more patients this medicine. I think the Hyundai Hope on Wheels program, I think the key word in there is hope. As an oncologist, as a scientist, the reason you do this is you want to make some kind of impact that's going to dramatically change the field. That's what I've always wanted to do. Like, I don't care what I do. I just want, someday when I'm gone, I want someone to say, he actually changed what we do in childhood cancer, and that's what I'm after. I have a unique handprint, just like every one of my patients has a unique handprint. You know, my handprint is unique, but it's not unique. I think some of the patients to deal with, there's a lot of common features across our handprints. So I try to share what are our commonalities as a way to inspire my patients, both in terms of telling them what I do as a researcher and what I've kind of gone through as a survivor. But then I also think our handprints are different, and I think talking about how everybody that goes through cancer is going to have different challenges, and just trying to give them the perspective that whatever comes their way, that I'm there to help them, my team's there to help them, and everybody around them is there to help them, and they can overcome these challenges.